Alright, so I just found out that it seems like all the classes are canceled today, so it seems like my audience may have doubled. I'm going to have to start this video by correcting a mistake I made in the last video, which was the tech code for subset that's not equal. This is not subset equal, it's subset not equal. So this notation will give you subset crossed out. What we want is subset with just the equal sign crossed out. So we want subset n eq, and for whatever reason a second q, just good measure I guess. And that will give you this notation with the subset symbol with an equal sign that's crossed out underneath, which is what we were trying to get, in fact. Alright, now we're going to do two more styles of proofs that will come up with sets, and the first one is the most basic. You might be asked to prove a situation where something is an element of a set, to just prove that something is an element of a set. And in order to do that, you just have to show that it satisfies whatever the criteria is that is given for entry into that set most of the time. What we're going to do is we're going to prove a claim that will actually be very useful to us and should hopefully be an obvious fact, and then we'll see how to prove it and be able to use it henceforth. So our claim is going to be that the set containing only x, so this is a set containing a single element, and that element is little x, is a subset of a set called big X if and only if little x is an element of the set containing big X, or the set called big X. And this is certainly something that should be true, right? If something is a subset, it basically gives us the definition of subset. Tiny, tiny little condition. So we're going to prove that this is true. This is an if and only if proof, so we're definitely going to want to have two cases. So we'll start by letting big X be a set, and that's going to be true all the time, so that'll be in our introduction paragraph. We're not telling you anything else about the set. We know nothing about this. We just know it's a set. So let big X be a set. And that's the whole introduction paragraph. Now we're going to start the next paragraph where we start one direction of implication. I'm going to start for fun by saying let little x be an element of big X. We want to show that the set containing little x is a subset of the set called big X. And so we need to show that all the elements of the set containing little x are contained in big X, which is pretty obvious, so we basically just have to state it. Let little a, we can't use little x, it's already been used. Little x is a specific element of big X, we've already fixed it. So let little a be an element of the set containing little x. Then little a is equal to little x, by definition of that set. Thus, a is an element of big X, and so every element of that set containing little x is contained in the set called big X, and so we know we have a subset relationship here. One of the important things about doing this particular exercise in class is that it forces us to be very, very careful with notation. It's easy to confuse the element of and subset notations, and they're very, very different things. Sometimes we will have a situation where we have a set of sets, and then it's possible for something to be a subset and also an element of the same set. We could have a set that contains maybe all of the integers and also contains the set of integers as an element, and then the integers are an element of the set and also a subset of the set, and it's important to keep these two things straight. It's also possible to have the integers be an element of the set without being a subset of the set. We could take, say, the set of all sets that we've looked at so far in class, and the rational numbers are an element of that set, but they're not a subset of that set because the rational numbers are not sets that we've looked at. So I'm done with one implication. Now I need to go the other way. Now I'm going to let the set containing little x be a subset of the set called big X. Therefore, since little x is an element of the set containing little x is an element of big X. This is by the definition of subset. So I'm going to write it. Now we just need to sum everything up. We've shown both directions, so we just need to write a conclusion. We have shown set containing little x is a subset of big X if little x is an element of big X. So that's it. And now that's something we can use, which is good and important because it's such a basic, trivial fact. The next thing that we're going to do one example of, the last thing, is just a proof that something is not a subset of something else, and that's actually a really, really easy proof. The two sets I'm going to look at, I'm going to look at the set containing, or the set of things divisible by 12 and the set of things divisible by 8. So I have x such that is written as a colon. 12 divides x is not a subset, so subset sign crossed out. This is that not subset equals that I was trying to do at the beginning that I did wrong. It's not a subset of the set containing all x, so that 8 divides x. We need to show that something is not true. We're trying to show that it's not the case that all the elements here are in here, and so in order to show that all doesn't happen, we just need one counterexample. So I just need one element of this set that's not in this set. Any guesses? If you're looking at the notes, you don't even need to guess because you're in the future where I've already written down the answer. 12 is contained in this set and is not contained in this set, so 12 is a counterexample to the claim that we have a subset relationship here. This is basically just a counterexample question. So we're going to say note that 12 is an element of the set of things divisible by 12. But 8 does not divide 12. And so 12 is not an element, so that's not in, that not an element symbol. Put that over here. Twelve is not in the set of things divisible by 8. And so, one sentence proof, I just have to conclude that the set of things divisible by 12 is not subsumed by the set of things divisible by 8. So we have 4 different types of proofs that could come up in these set situations. We have proving that 2 sets are equal. To do that, you just have to show that each one is contained in the other. That contains a proof of a subset relationship, which you could be asked to do. In fact, you will be, which is just showing that all the elements of one set are contained inside of the other set. I did one example to try and show both of them so that you guys can get on with your life and don't spend all day watching videos of me talking. And hopefully that's enough to see both relationships. The third kind is that you could be asked to show that something is an element of a set. That's a really quick proof. You just have to show that it satisfies the requirement. To show that something's not an element of the set, you just have to show that it doesn't satisfy the requirement. If the set's in list notation, you can just state that something is or is not an element because you can see all of the elements, and that's all you need. You just say, look, it's not on the list. You don't need to prove that. If something is in set builder notation, like we had here, we needed to say 8 doesn't divide 12, therefore 12 is not in the set of things divisible by 8. We had to explain why it's not there because it doesn't satisfy the requirements for belonging in that set. And the last thing is that you might want to show that things are not equal or are not subsets of each other, and there we're doing a counterexample. We're just giving one example to show that this isn't always the case, because saying that 2 sets are equal or 2 sets are subsets of each other is claiming that something's true all the time, and you just have to show it's not true all the time. The only thing that can get tricky here is make sure that you're giving a counterexample for the right direction. It's not true in both directions. It's not true that everything divisible by 12 is divisible by 8, and it's also true that not everything divisible by 8 is divisible by 12. So make sure that you're showing the right counterexample. I was going this way, so I needed to find something divisible by 12, not divisible by 8, not the other way around. So I'm going to ask you to do the examples that I wrote in black on your assignment sheet, and of course also do the ones that I wrote in blue and submit on overleaf. The ones that I wrote in black I am going to collect. I'm not sure at this point if I'm going to look them over and try and assign a grade, or if I'm just going to give a quick run through and see if it looks like you actually did those examples. Most of them, possibly all but one of them, I think are not proofs. They're just trying some things using the definitions, and since you have the book to look at, you should be able to get a really good handle on the definitions. I will start class on Tuesday answering questions on section 10, and because of that I'm going to ask that you read not only section 10 but section 11 in preparation for that class. At least give it a really good skim, maybe take some notes. Section 11 is a nice one to rush through a little bit because it deals with notation and terminology, and that is something that you can actually get from the book. So instead of skipping section 10 altogether, I'll answer questions on section 10 at the beginning of class, and then we'll get into doing real notes on section 11. And I'm going to try and give some time for you guys to work some examples in groups as well. So, stay warm, have a great weekend. Thank you guys for watching this whole thing. Anybody who has gotten through this can, why don't you write, I'm trying to think of something kind of silly. Why don't you look up how to write a smiley face in Detectify and put a smiley face on your next homework assignment, the one that's due on Tuesday, and I will give you a bonus point on one of the problems as a reward for that. Alright, so thank you for bearing with me this entire time. Bring in your black problems to hand in on paper, turn in the blue problems on overleaf on Tuesday, as per usual, as per our schedule, and hopefully we won't actually lose any time due to this snow day. Have a great weekend.